All right, it's recording. Morning, everyone. It's Tuesday, November 12th. The usual suspects are here in the first period geometry class. And we're going to discuss section 4-4, which is proving lines parallel. I have a feeling there might be a little proofwriting today. We are on page 162F in Braille. Bottom of page 162 in our print version. So your Braille copy has a very substantial and pretty nice tactile, looks like. Let's make sure it has everything on it. You have two parallel lines running east to west, 9 o'clock to 3 o'clock. And they have the little parallel arrow indicators in them. Drawing them on the book. Make sure the camera looks pretty good. Move it over just a little bit. There we go. And they have the little parallel on the right. They have that little parallel arrowhead. The top line is line what? You find that?
Oh, A.
A, good. Yep, it's at the top right of the arrow. They're not always the same place, so you got to find them. Typically, on your drawings above the arrowheads or around the arrowhead, they'll have a name of the line. And then you have your bottom line that's parallel to A, correct? And what is that?
B.
B, good. And then there's a transversal. And it's going from about 7 o'clock to 1 o'clock or 8 o'clock to 2 o'clock. And they have not labeled the transversal. And then there are two tick arcs, right?
Yeah.
One and there. What kind of labeled 1 and 2? What kind of angles are those that you learned about from the last section? Congruent, but what are they called? One's on the exterior, one's on the interior.
Transversal.
It's the
Corresponding?
Corresponding. They're corresponding. Yeah, one's on the exterior, one's on the interior. They different vertices on the same side of the transversal. Corresponding. How can we remember that? Let's think of a memory trick. Exterior, interior. Someone on the outside is writing to someone on the inside, like they're in jail, and they're corresponding with them. All right.
Mm-hmm.
So they correspond. To correspond means to talk to each other or to write each other. So someone on the outside is corresponding with someone on the inside, and the on the inside means in jail.
All
right. So can you remember that now? Mm-hmm. Corresponding. That's a little memory trick. Sometimes we just make up things like that and then we can remember them. All right. So the very top of the page discusses postulate 4-2. Right? It says in a plane, if two lines are cut by a transversal so that a pair of corresponding angles is congruent, then the lines are parallel. So it's kind of taking the reverse from when you learned in the previous sections about corresponding angles and that they were congruent. Well, now this is doing the converse, isn't it? If we have two corresponding angles, then we know our lines are parallel, right? Remember that from chapter 1 when we would make a statement and then we would make the converse to the statement and test that out. And if we could do the statement front and back, well then now we have this postulate, all right? Okay, so let's see, we can use this postulate, it says on the bottom, so turn the page and let's see how our, what do they have on the next one? You can use the postulate 4-2 to To find the angle, measures of corresponding angles so that two lines are parallel. And you know what? They did do a decent job in the example on the next page. It's a drawing in the book, or a photograph in the book of it looks like some sort of highway system. And but they didn't mess with trying to create that in the background. Sometimes they do that, Rahel. They'll put the photograph behind it, and it'll be a mess. And this is actually very nice. It just has two parallel lines. It doesn't show them with the little parallel indicators, but they're gonna have us prove that. They're gonna give us some information in our problem in the example number 1. But we do have two parallel lines that are running from about 10 o'clock to 8 o'clock each of them. See those? And they use those heavy dots. Yeah, and we're on page 163A. Find it?
Yep.
Okay. And one of them is labeled L. One of them is labeled little m, italicized M. And that's off to the right, top right. And there's a transversal that runs from about 10 o'clock to 4 o'clock. And they haven't labeled that line, but they did label the angles on the interior, and it kind of runs into your line. So you have to make out that there's an angle 3 and an angle 2, and then there's an exterior angle at angle 1. So 1 and 2 are a linear pair.
It's kind of hard to fill the numbers in here.
Is because they're very close to the lines. So angle 1 is the exterior angle on the very bottom. And then angle 2 is just above that, kind of headed towards 10 o'clock. It's a linear pair with angle 1, and it's on the interior. And angle 3 is on the opposite side of the transversal, and it's a linear pair with angle 2, and they're both on the interior of your parallel lines. So angle 1 and angle 3 are a vertical pair, and angle 1 and angle 2 are a linear pair. Did you find them?
Yep.
It's really a tight tactile. And what it is in the book is a drawing. It's a photograph of a highway, a top view, like if you were flying over a freeway or a highway and looking down upon the infrastructure of the road. It's showing the two of the lanes running parallel, and then one of the like intersections that it intersects with running as the transversal, and it's creating angles. And so that's what they're trying to show, is this top-down view over the top of a highway system. And it says the intersection at the right is called a trumpet interchange. So it's some sort of civil engineering term for creating highways. If the measure of angle 1 is 13x minus 8, and the measure of angle 2 is 12x plus 4, find x so that L and M are parallel. So you know information now around knowing that you need to prove that you have parallel lines. Well, then you know that you have to have corresponding angles or a linear pair. And so then we know if these are parallel, we know, or if we're going to prove these are parallel, we know we're going to do something with 1 and 2 to make sure that happens. So when you think about all the stuff that you know about angles and parallel lines and transversals, what is the relationship of 1 to 2, the measure of angle 1 to the measure of angle 2? What kind of angles are they to each other? They're linear. And you know about linear angles. 180. They add up to 180, don't they?
Yeah.
They add up to 180. So So if you can follow the proof. Let's follow the proof that they do. So it says from the figure, so below your figure, it says from the figure you know that angle 1 and angle 2 are corresponding angles. And they're not. They're a linear pair. So there's a typo in here. So according to the postulate, if measure of angle 1 equals measure of angle 2, then line L and M are, oh man. Oh, you know what? Okay. This is really a bad drawing and a bad tactile. All right, everyone. Here we go. Actually, angle 2 is the top. What they're trying to indicate for angle 2 is the interior angle above. So your top line, your top parallel line, angle 2 is supposed to match the one that's that interior one, and then angle 1 would be just below it. So they are corresponding angles. So in this case, we could make them equal. Okay. All right. Whew, they didn't even in the photograph. It's hard to make that out.
Yeah.
They don't even do that. All right, that's a bummer. This is not a good problem all the way around.
It looks linear to me.
Yeah, it looks linear to me also, but I guess what they're trying to indicate when I'm taking a look at what they're doing in my teacher book, that actually they wanted that 2 to label it. They should have spread these lines further apart. They have them too tight together, and so you can't tell. Even in the picture in the print version, you can't tell where angle 2 actually goes to. That's not nice.
Yeah.
All right, so we're going to take it as corresponding angles because we want to use this new postulate. So then we make these equal to each other, because notice that we read measure of angle 1 equals measure of angle 2, therefore line L would be parallel to line M. So measure, they write that out first. The measure of angle 1 equals the measure of angle 2, and then right below it they give the reason, right? It's going to be in proof format, and the reason is we're going to use corresponding angles. Then we plug in, they plug in 13x minus 8 equals 12x plus 4, correct?
Mm-hmm.
It's using what property? The good old substitution property, right? Where we get to plug in the information. Then we start using our algebra principles. So we subtract 12x from both sides. So it says 13x minus 12x equals 12x plus 4x minus 12x, because we got to get our x's all to one side, right? So that's just using our subtraction property of equality. They kind of listed it out more than saying the subtraction property of equality. Then turn the page. We're going to finish our proof. So it's just on a plain Braille page. So we're on 163B. And at the very top it says x minus 8 equals 4, because they just simplified, right? We had to subtract the 12x from both sides, so 13x minus 12x just leaves us with 1x, or x, right? And we still have the 8, and we still have the 4. And then we have to add 8 to both sides, because we want to get x by itself, so x minus 8 plus 8 equals 4 plus 8. So that's using our addition property of equality, adding 8 to each side. And then we simplify again, and we get x equals 12. So we're not done, because they asked us what the measures of the angles were, or would be to make them parallel. So we got to plug the 12 back in. So it says measure of angle 1 would equal 13x minus 8. That's interesting how they dropped down a line there, didn't they?
Mm-hmm.
And 13 open paren, 12 close paren, because x we're going to substitute in, minus 8, or we simplify it and it's 148. So each one of those angles is 148 degrees. All right?
Yeah.
Phew! All right. So then it says under your turn, Oh, they also did measure of angle 2, didn't they?
Yeah.
Yeah.
Just to prove it. Measure of angle 2 equals 12x plus 4. Then they substituted in 12 times 12 plus 4, or 148. So there we go. All right, now under your turn it says, find the measure of angle 3 and name the type of angle pair by angle 2 and angle 3. Well, all right, so hopefully we're going to, it should be 100. Yeah, it's looking to me like they're labeling, and it looks in my book too, that they're labeling the alternate interior angle to angle 2, right? Or the vertical angle to angle 1. So just hearing those words and knowing what you know about alternate interior angles and vertical angles, what do you know about angle 3? What does it need to be if you already have figured out the measure of angle 1 and angle 2?
Should be.
So you don't even need the drawing, really.
Yeah.
If you know that angle 1 is 148, and angle 2 is 148, and you know that angle 3 is a vertical pair to angle 1, angle 3 is a vertical pair with angle 1, or angle 3 is the alternate interior pair with angle 2. What do you know about alternate interior angles or vertical angles?
180.
They're congruent.
They're what, Stormy?
Congruent.
Say it louder.
Congruent.
Congruent, that's right. Vertical angles are always congruent. Alternate interior angles are always congruent. So if you know angle 1's 148, what's angle 3? 148, that's right. If you know angle 2 is 148, what's angle 3?
148.
148. And it's because of those two reasons, right? Alternate interior angles are congruent and vertical angles are congruent. All right, it says make a conjecture about the relationship between angle 2 and angle 3 that must be true for L to be parallel to M. So according to your postulates and what you've been doing, what has to be true about angle 2 and angle 3 in order for L and M to be parallel? They have to be what?
Alternate exterior.
Well, they're alternate interiors, but they have to be congruent. That's what they're looking for, is just making sure that you're very aware that if you want parallel lines, those have to be congruent. So angle 2 has to be congruent to angle 3 in order for those lines to be parallel. Okay?
Yeah.
All right. It's kind of redundant. All right. Let's move forward to... We got 2 more postulates. So it says on page 163C, it says example 1 illustrates 4 additional methods for proving that 2 lines are parallel. These are stated in theorems 4-5, 4-6, 4-7, and 4-8. Probably, if you just stop and think about it, all right, we already have a postulate that says that if you want to prove that 2 lines are parallel, you gotta show that the corresponding angles are congruent. Well, once you show corresponding angles are congruent and 2 lines are parallel, we could have these 4 other theorems that will also show that the lines are parallel, and it has to do with all the stuff that you've learned up to this point, right? We're going to have probably some sort of theorem about alternate interior angles being congruent, therefore your lines are parallel. We're probably going to have something about alternate exterior angles being congruent, and so your 2 sides are going to be parallel because you've already learned that. We're probably going to have something about consecutive interior angles being supplementary, adding up to 180, so then you know your lines are parallel. And I bet we're going to have something to do with our perpendicular lines, because that's what we've learned, and we've learned that if we have a perpendicular line, therefore we then have 90-degree angles all the way around, and 90-degree angles are congruent, are equal to each other, so therefore our lines have to be parallel. So again, in geometry, in Euclidean geometry, in linear algebra, in mathematics period, we figure these things out and then we state them, and they're accepted as true so that we can move forward with other things. All right, the logic. So let's take a look at 4-5. We're gonna have a and a drawing to go with each one. All right. So we are on page 163D, and this is Theorem 4-5. Let's read the top first, the words in Braille, and print. We're at the bottom of page 163, and then we'll go ahead and take a look at the model and go, yep, that's what they're talking about. So it says, in a plane, if two lines are cut by a transversal, so that a pair of alternate exterior angles alternate interior angles is congruent, then the two lines are parallel. So they give a model. Down below your words there, they have a set of parallel lines running from 9 o'clock to 3 o'clock, or 3 o'clock to 9 o'clock. You have line A and line, has it got B or?
Yeah, B.
Yeah, B.
A weird looking B in my book.
Yeah,
Oh, there we
like
go.
an L kinda.
Yeah, I had something on the page. I wiped it off. All right. A crumb got in the way. Okay. So we have A and B. They have their little parallel arrow indicators. And then it shows the transversal with the alternate interior angles. And those tick arcs are showing congruency of angle 1 and angle 2. Okay. So this is just the converse of what you learned in a previous section. You learned if you have two parallel lines with a transversal, it creates alternate interior angles that are congruent. Now it's telling you, if we show you a drawing with two, or we tell you even in a story problem that the alternate interior angles are congruent, or the alternate interior angles equal 80, then you know that the lines that were created that were drawn to create those angles are parallel. Okay, it's the converse. Okay? And then down in symbols underneath your drawing, it says if angle 1 is congruent to angle 2, then A is parallel to B. That's a really good review of some Braille, isn't it?
Yeah.
Yeah. If angle 1 is congruent is that dot 4 WH equals, right?
Mm-hmm.
Angle 2, then A is parallel, and that's EDL, to B, and then they do period, punctuation indicator, period. Okay. Good review of some basic, and your angle indicator is ED and then OW. Okay. In print, Angelica, it's that little angle indicator that looks like a little mini angle, and
Right.
the congruency is an equals with a little tilde up above it.
Till equal.
Yep. And then parallel is two long little lines next to each other that look parallel. Okay.
I had an Arabian with that same exact mark on her butt.
What's that?
I had an Arabian with the same exact mark.
A little parallel on her butt.
Yeah, like 11.
Yeah, a little 11.
She was
All
an
right.
Arabian. She was paying though.
Turn the page. It's going to discuss Theorem 4-6, so it's going to be the converse of what you learned about alternate exterior angles. So it's going to sound very familiar, but now they're going to use alternate exterior angles
Next
as the
page.
indicator. The next page on 163E. Okay.
3E.
Says, in a plane, if two lines are cut by a transversal so that a pair of alternate exterior angles are formed and they are congruent, then the two lines are parallel. So again, we're just stating the converse of what you've learned already. So here we have on a drawing two parallel lines. It's just really good practice of getting used to looking for parallel lines and angles, and a review of all this vocabulary you've been learning and all these names of all these angles. So we have a line A and a line B again, and a transversal running from about 2 o'clock to 8 o'clock. And then notice now they've used tick arcs on the alternate exterior angles, and it's number 3 up in the top right
And 4 on the bottom left.
and number 4 down in the bottom left. Alternate exterior angles. And so if those are congruent, those tick arcs show congruency, then you know, based upon Theorem 4-6, that A and B are parallel. You could prove it. And then down in symbols underneath the drawing, they review again. If angle 3 is congruent to angle 4, then A is parallel to B. All right. Turn your Braille page. I have a page break at it's on the page, and it's 164. And this is Theorem 4-7. So now it changes just a smidge. We got to get out of congruency land and think about consecutive angles and what you know about consecutive angles. Consecutive angles are on the inside, on the same side of the transversal. And if you have parallel lines, they're going to be supplementary. They're going to add up to 180 degrees. You learned that in a previous section, that consecutive angles of parallel lines being cut by a transversal will be supplementary. So now we're going to state the converse. In a plane, if 2 lines are cut by a transversal so that a pair of consecutive interior angles is supplementary, then the 2 lines are parallel. So they show a drawing. And notice there's no tick arc for these. They're not saying they're congruent. What they're going to have to do is give us, and they didn't in this one. I wish they would have went a little bit further. And they did in symbols, though, down below, so that helps us. They will have to give you the measurements of the angles in order for you to be able to say that the lines are parallel. Or they'll have to give you that they're supplementary. And so they did in the words down below for angle 5 and angle 6. Notice they're both on the interior of your parallel lines, A and B, with the same transversal position at 2 o'clock to 8 o'clock, and you have angle 5 and angle 6. And then down below, this is where it's very important to read this stuff. It says, if the measure of angle 5 plus the measure of angle 6 equals 180, then A is parallel to B. So if 5 was 120 and 6 said 60 on it, then you would know, aha, because of Theorem 4-7, I know that if I have consecutive angles that are supplementary that add up to 180, then I can tell you for sure that A and B are parallel. All right? Is that helpful? Okay. All right. All of this is just adding to our knowledge bank of this Euclidean geometry, because we're getting to a space where we're going to end up starting to prove that a parallelogram is a parallelogram based upon all this stuff.
This next one is really interesting.
All right. So the next theorem on the next Braille page is 164A. It's Theorem 4-8. At the top of your Braille, it says, in a plane, if 2 lines are perpendicular to the same line, then the 2 lines are parallel. So then it shows a drawing, and you learned about perpendicular transversals. Yeah, and those are corresponding angles, exactly. So this taps into the perpendicular rules that you learned previously, and then also it's utilizing the corresponding angles postulate, isn't it?
Yeah.
Yeah, and you learned about if you've got a perpendicular line, it creates a 90-degree angle. There it's showing that little 90-degree angle indicator. Then you know if that's creating a 90-degree angle indicator, it's going to be 90 degrees all the way around on the top and the bottom, right? And so then, of course, we have corresponding angles that are congruent to each other. We also have alternate exterior angles that would be congruent to each other if we drew those. We have alternate interior angles that would be congruent to each other. We have consecutive angles that would be supplementary because 90 and 90 is 180. So this whole thing is using all of the principles that we've learned. And so it should be a no-brainer to go, oh, well, yeah, those lines are going to be parallel, right? A and B are going to be parallel. So if you were in a situation where you had two lines or line segments and a perpendicular line to it, you would then know, okay, if they're 90 degrees, I know those lines are parallel to each other. And this, we're going to use this theorem later to prove that a square is a square and a rectangle is a rectangle because of the parallel sides and the 90-degree angles. Okay? And then down at the bottom of your drawing, again in symbols, this then reviews our perpendicular symbol. It says if A is perpendicular, EDP, to T, and B is perpendicular to T, then A has to be parallel to B. So there's your perpendicular braille and then your parallel braille. All right?
I almost read it as that and not T.
Yeah, the T sitting there by itself, isn't it?
Yeah.
But when you have the other mathematical symbols around it, then you know that it's not literary and now it's Nemeth. Yeah, so, yeah, did it have a letter sign on it?
Yeah, mine does.
On your T?
It did on
your
the
line.
example.
On your line. But
On
in the actual expression, from what I understand, the reason why it doesn't have a letter indicator next to it is because it's right after the EDP, which is a Nemeth symbol. So the EDP would mean, oh, well, that's a Nemeth symbol. That means perpendicular. So I'm going to have a letter or a number that follows that. I don't need to know that it's a letter or a number. I just know that it is. Okay, that's why they don't. Yeah, so you got to kind of get your head into, oh, I'm reading some Nemeth here, and so it's not that. Just like the B by itself would not be B, right? Yeah. Okay. A little trickery there, but you start to get used to it. Okay, let's see. Turn the page, and now we're going to bring together, which is really nice, because that was a lot of information. So a concept summary of what are the 5 ways you can prove that two lines are parallel. And again, this is building you up to be able to prove later, hey, we could say that a parallelogram is a parallelogram, or a rectangle is a rectangle, or a square is a square, just by using these 5 different ways to say, well, I know because of these rules. So the first one, it says you could show that a pair of corresponding angles is congruent. Now this is where T is that. Right? Show that a pair of corresponding angles is congruent. So that's the first thing we learned. Right?
Yeah.
All right. Then we could show that a pair of alternate interior angles is congruent. So if we have a pair of alternate interior angles, boom, we know that it's the parallel lines. Then we could show that a pair of alternate exterior angles is congruent. Or we could show that a pair of consecutive interior angles is supplementary, using that rule that we learned. Or we could show that 2 lines in a plane are perpendicular to a third line. 5 ways we could show that lines are parallel to each other. All right? So now we're going to practice that. We're going to practice which concept, which way, which theorem or postulate are they using in order for us to prove that a couple of lines are parallel to each other. So next page, 164C, and we're down in the middle of the page in print. Up at the top it says examples, and we're on number 2. It says identify the parallel segments in letter Z. And so it has this big print letter Z as our tactile. So let's take a look at that. So this is a print version of a letter Z. If you start in the top left corner, you have an arrowhead, and you have a line A, or a point A, capital A, directly above the little button there, Abby, a little button, and go immediately right through the 3 o'clock position. You come to an end point. This is a ray, isn't it?
Yeah.
Indicating that end point is capital B. They didn't use a button. It's just then assumed once it's connected to a line that's intersecting with it, that's creating a vertex B there. Follow that down diagonally from about 10 o'clock to 8 o'clock. And we come to another vertex point, capital C. That's an end point to a ray that goes immediately through 3 o'clock through capital point D and an arrowhead. So if you start at A, up in the top left, go immediately right to B, then go diagonally down to C, and then immediately right to D. That's a print letter Z. That's what they're saying, is identify the parallel segments in the letter Z.
Oh, Z look like that.
So it also indicates to us that ABC, angle ABC, see how this is making us practice our angles, right? And the way we'd name our angles, angle ABC, B being the vertex, angle ABC, on the interior of that, how many degrees are they stating that is?
40.
40, good.
And
Then
same with
angle
BCD is also
BCD
40.
is 40 degrees, right? Okay. Or we could say angle B is 40 degrees and angle C is 40 degrees. Why could I name those angles just by B or C? Why could I say that angle B is 40 instead of C?
We only share one line.
Yes! Nicely done, Stormy. They only share, there's no other, they only share one ray each, don't they? Or one, B is not sharing itself with anything else. So if we wanted to, we could say angle B and angle C. But we're gonna be really, really thorough and say ABC is 40 and BCD or DCB, we can name them backwards, can't we? Is 40. So those two angles are equal to each other, aren't they? They're congruent. ABC is congruent to BCD. What kind of angles are those when we think about A, B, and CD? If we think about wanting to prove that A, B, and CD are parallel, what kind of angles are those?
Are they acute?
They're not adjacent.
Acute.
They are acute, but what are they to each other? In order to prove, you got to prove that A is congruent to CD.
Are they alternate exterior?
Alternate interior.
Oh, yeah.
Because imagine, if you will, Bryant and everyone else, that the lines would extend into infinity through the 9 o'clock and 3 o'clock position. So past C, a line would extend off to the left, and past B, it would extend off to the right. And then from B to C, that line segment, through B, it could extend up through 2 o'clock off into infinity, and that's your transversal. And down through C, through 8 o'clock, it could extend down into infinity. And now you've created you have a transversal. Your BC is your transversal of AB and CD. You see that?
Mm-hmm.
So then they're alternate interior because they're on the inside of your parallel lines on opposite sides of your transversal.
Okay.
And when alternate interior angles are congruent, then we know our lines are parallel, right?
Yeah.
Yeah.
Okay. And that's what it says down below. Underneath your graphic, it says angle. Actually, does it say up top first angle? Yeah, up at the very last line at the top, it says angle ABC and BCD are alternate interior angles. See that up at the very top?
Yeah.
Okay, then you go down below your drawing and it kind of proves it. It says, well, the measure of angle ABC equals the measure of angle BCD. Both angles measure 40 degrees. Therefore, AB, line AB, is parallel to line CD because of Theorem 4-5. Right, so we proved it. Just by stating that, well, I know that Theorem 4-5 said if alternative interior angles are congruent, 40 equals 40, then I know that it's created two parallel lines. AB is parallel to CD. Not by looking at it. We can kind of look at it, but we want to be able to prove it. We can't say, well, it looks like they're parallel. That doesn't work. We got to say why. And they're parallel because alternate interior angles are congruent. All right, turn the next page. Now we have a print letter F.
I like it.
All right,
Actually,
a print letter F.
I know what it looks like.
Okay, and it says identify any parallel segments in the letter F and explain your reasoning. So we have a line at the very top running east to west, and it's got a point and an end point. The end point is G, and the point that it's going through is Y. It's got an arrowhead on the right.
Yeah.
At point G, we have a line going from 12 o'clock to 6 o'clock, a ray actually, going from 12 o'clock to 6 o'clock from G through A. So we have ray GA. Go back to about the middle between, it's not exactly a midpoint, but it's getting close from G to A, and there's a point R. And then from point R, go immediately to the right through the 3 o'clock position through point D, and then you have an arrowhead, so you have ray RD. That's a print letter F. Now in the top right corner, they're labeling YGA 90 degrees. Angle YGA is 90 degrees. We could also call it angle YGR.
Is that a right angle look like?
Or we could call it angle G. Yeah, why is it a right angle, Abby? It's 90 degrees. Then notice that directly below that angle DRA, or we can't name an angle R because R shares itself with DRG, doesn't it? So we just have to name it DRA or ARD. That's stating 90 degrees. So there's a couple of reasons we could say that we have a set of parallel lines here. First, what's our set of parallel line segments? Which ones are parallel to each other?
GY and RD.
GY and RD. Those are the ones that are parallel to each other. So that's what you'd say. You'd say, well, GY is parallel to RD because, and why do you want to say that? Why are they parallel to each other? Prove it. Can't say it's because they look like it.
They're congruent.
They're congruent. Well, the line segments are not congruent. What are congruent to each other?
They don't touch.
That's not because they don't touch. We have to use our logic and our reasoning. So GA is a transversal. GA, the one going up and down from 12 o'clock to 6 o'clock, is our transversal of GY and RD. And what kind of angles has it created? What kind of line is GA to the other two? What is it doing? What kind of line is it? Starts with a P.
Parallel.
No.
Perpendicular.
Perpendicular. What does perpendicular mean?
Cross.
Perpendicular. Bryant, what's perpendicular mean?
They meet.
Nope. Perpendicular means it intersects at what kind of angle?
Right.
A right angle. That's right. Perpendicular, 90 degrees. And so we have 90-degree angles all the way around here, don't we? They equal each other. So we know that GY is parallel to RD because of our perpendicular rule, right? We also could say that they're parallel to each other because we have corresponding angles, don't we?
Yeah.
YGR corresponds with DRA. One's on the interior, one's on the exterior, and they share different vertices. So there's two reasons why these lines are parallel to each other. Why the top of our F is parallel to the middle line of our F. It's because of our perpendicular rule and our corresponding rule. All right? Just making you think. You can't just say because it looks like that. All right. What I'm going to do is I'm going to finish up in the next 5 minutes talking my way through the rest of this stuff, and I'll send you the link and you can listen to it. The bell's going to ring here in a minute. What I'd like you to do is number 1 through 7 on page 165. Number 1 through 7 on page 165.
Could you write the things down that I'm supposed to do?
You need to. Get out a piece of paper and write it down.
All right.
Page 165, number 1 through 7.
Test two.
And you got to do your quiz. That's right. You can write that down. All right, and you guys just pack up and head out and ignore me. I'm going to keep talking and recording this so that you can have it for later, okay?
What is the page number?
Okay.
Page 165, number 1 through 7. Okay, on the next drawing, which is on page 164E, it says find the value of x so that BE is parallel to TS. Notice that you have a shape here. You're going to learn later. You probably already have learned in other classes that this shape
Every time when I was in my
is a parallelogram.
You might. You want to?
And we have a line at the top of the page and a line at the bottom of the drawing, a line segment. The top left-hand corner, it's a capital B. Then go clockwise. Top right-hand corner would be E. Top left-hand corner would be S. And top right or bottom right-hand corner would be S. Bottom left-hand corner would be T. So we have segments here. We have BE at the top, and we have ES on the right-hand side. We have ST or TS at the base, and then we have BT or TB at the left. Up in the top left-hand interior of our parallelogram, they're saying that that is 4x plus 4x plus 8. In the top right-hand interior angle, they're saying that that is 2x plus 10. And in the bottom right-hand corner, they're saying that's 5x plus 2. So they're asking you to find the value of x so that BE is parallel to TS. Well, if BE is parallel to TS, we have two transversals. We have BT on the side and we have ES on the side. Things have been created then. If we imagine BT is a transversal, then 4x is an interior angle. And if we imagine SE as a transversal, 5x is an interior angle. Also, 2x plus 10 is an interior angle of SE. They're on the same side of the transversal, so we have consecutive angles going on here. We also then could say, well, BT is parallel to ES. We have some transversals with ST and BE, and the angle at angle B, at vertex B, 4x plus 8, is congruent to the angle S because they would be alternate interior angles. So you have two ways you could solve for x here. You could either make B equal to S, or you could make S plus E equal 180 degrees because they're consecutive. What they did in their proof on this particular problem is they showed that angle E and angle S are consecutive, and so they added those two together, 2x plus 10 plus 5x plus 2, combined like terms, used our addition property and subtraction property of equality and our division property of equality and solved for x. And on the next page, they walk you through that proof on page 165 of doing all of that. And you can read through that on your own. And therefore, x equals 24. You plug back in 24 and you're able to figure out the measure of your angles. Then they ask in the your turn at the very bottom of the page 165 for you to use the same example, but now prove that BT is parallel to ES, which are the two sides. And so that's what I explained earlier, is that angle B, 4x plus 8, is an alternate interior angle to angle S. So you could make 4x plus 8 equal 5x plus 2 and solve for x in that situation. All right, and it'll be a slightly different answer if you did that to prove that, as it should be, because they're equal to each other, and angle S and angle E are not, they're consecutive. So that is that's the last of that section. And then what you guys can do is work through problems 1 through 7 on your own. There's several tactiles, and it's going to be using the theorems that you've learned to prove why certain lines are parallel to each other. So review all those theorems and those rules and put those in your head as you're proving these. You'll also have some finding values of x. So remember how angles relate to each other. Are they congruent? So you set them equal to each other. Or are they consecutive? If they're consecutive, then you have to add them together and make them equal 180. All right, that's it for this lesson. I'm going to wrap it up, post it to YouTube, and send you a link. Have a good day.
There you go.